Hello friends, in this video we will learn how asymmetric key functions to achieve end-to-end encryption. Asymmetric key is also called as public key encryption. Why? We will understand in a minute. Asymmetric key is a pair of two keys, public key and private key. By its name you can understand public key I can share with anyone, but private key is highly confidential and should always be private to the owner only. Why? Let's understand. Public key is used to lock the information and private key is used to unlock the information. Suppose if you want to send message securely to your client, you will use your client's public key to lock the message and your client will use its private key to unlock the same message. Don't worry at this point. I am going to show you step by step how messages are encrypted and decrypted at both ends shortly. How public keys are exchanged. Public keys are contained in the app owned certificates, which they present to each other during the handshake process. After successful key validation, both parties will store the keys in their trust store. As you can see, Service A trust store is storing Service B public key file, and Service B trust store is storing Service A public key file. Let's understand this with the help of one example. Suppose we have two services, Service A and Service B. Now we will see how both parties use public key to encrypt the messages and private key to decrypt the messages. Here we will assume that both services have already exchanged their public key securely. You can see here two types of stores, trust store and the key store. Trust store will contain other client certificates that are trusted during the handshake process, and the key store will contain the public and private key certificates that are owned by service A itself. I hope you understand the difference here. Trustor will contain public key files of external services that it has trusted during the handshake process, whereas Keystore contains private and public key files that are owned by Service A itself. Service B will also have the same setup to store the trusted public key certificate files and the owning certificate files in the key store. Service A wants to send a hello message to Service B. So it will first encrypt the message with service B public key, which it will retrieve from the trust store, encrypt it, and send it to service B. Service B will receive the encrypted message. It will pass it to the decrypt function to decrypt this message with its private key, and this message is finally converted to plain text message. You can see here. The same process is followed when the message is sent from service B to service A. Service B will first encrypt the message with service A's shared public key and send it to service A. Service A will receive the encrypted message and pass it to decrypt function. The function will use the private key to decrypt the message and convert the message into the plain text. Here we have learned that a message will be encrypted with the receiver's public key only, so that the receiver can only decrypt with its private key, and nobody else over the public network can read it. One of the examples of asymmetric key encryption we can see during the TLS handshake process, where an asymmetric key pair is used to securely exchange the symmetric key between the client and server to establish a secure HTTPS connection. Thank you for watching this video. Happy learning and keep sharing.